Hello everyone, my name is Harsh and I'm an engineer at LocalStack. Today I will be presenting my talk on building automated continuous integration workflows for your AWS cloud and serverless applications using LocalStack. The focus of the talk would be on using LocalStack, our primary driving force, as a local AWS emulator to mock Amazon Web Services APIs for development, testing, and learning. Let us check out the agenda for today's talk. So first of all, we are going to discuss what LocalStack is in essence and do a very quick start, basically a hello world example with LocalStack and how you can get it up and running using our standalone command line interface. Next, we will talk about LocalStack and Terraform integration and how you can test this infrastructure as a code configuration on GitHub Actions. Lastly, we will briefly discuss about our advanced collaboration features using LocalStack Cloud Pods and how the engineers can basically make the best use of it. So let us address the first question that we have. What exactly is LocalStack? So in essence, LocalStack is a cloud service emulator that runs inside a single Docker container on your laptop or your desktop or your CI environment. For the end users, it basically allows them to run over 80 plus AWS services pretty much locally. It can simply go from creating S3 buckets on your local machine to spinning up EC2 instances, deploying an entire application via Cloud Development Kit or maybe Terraform and much more. So everything, as I mentioned before, is self-contained inside a Docker container, and all of the resources that are being available to you is epithermal. It just means that if you're spinning down LocalStack, all of these resources, all of the infrastructure that you created will simply go down. And LocalStack also offers you a standalone CLI, as I mentioned before, but also a lot of wrapper scripts around things like Terraform or CDK or SAM, so that you can make the best use of LocalStack with the ever-growing ecosystem around AWS itself. So the entire purpose of a project like LocalStack is to drive local cloud development and collaboration and to pull the engineers out of these inefficient development and testing loop while saving all of these costs. For many users, this has been a game changer because LocalStack allows them to mimic production environment as closely as possible. So to use LocalStack, you can pretty much use our LocalStack CLI, and this can be completely installed using Python's package manager, which is pip. And we also offer an AWS CLI wrapper, which is AWS CLI-local. And on a local machine, you can just write AWS local so that you can pleasantly mock your API calls without sending anything to AWS at all. Let us actually check out some very basic examples to see how this exactly works out. So first of all, we will start LocalStack in the detached mode inside a Docker container. And to do that, we are just going to specify LocalStack start-d, and this will start the LocalStack in a detached mode. Next, we are just going to copy paste a few commands over here. So here we have a few basic commands to actually create a bucket. So we are just going to do that. We are going to save some of our content inside a file. And then we are just going to upload this inside our S3 bucket. So once we have done that, we can actually check the content of our S3 bucket. And as you can see, hello world is present over here. Not just S3 buckets, but we can also work with some more exotic AWS services like SQS. So in this case, we can just specify AWS local to create an SQS queue. And you can see that LocalStack is specifying to localhost 4566. This is a port where all of the LocalStack services are basically listening to. Next, you can just send out a very basic hello world message to that particular queue. And you can see the message ID over here, which signifies that the message has been sent. And you can, of course, receive this particular message. And this will contain the hello world body right here. So again, this was a very basic hello world example. You can further explore LocalStack and you can further experiment with this. Once you are done, you can just say LocalStack stop, and this will entirely spin down your LocalStack instance. Cool. So we can jump over back to the slides and we can talk about the main stuff in the room. So since the focus is upon testing an AWS app on GitHub Actions, we are going to use Terraform for that. For a lot of people who are not familiar with Terraform, it's an infrastructure as a code framework, and it very nicely fits in with the LocalStack's integration suite, which I'm going to demonstrate. Terraform basically allows engineers to create resources in a declarative way, And Terraform basically creates a plan which is then applied to these resources. Pretty cool, yeah. So previously you used to write these Terraform scripts which can create an infrastructure on AWS. The only difference is we are going to create this infrastructure on LocalStack, and we are just going to use either the Terraform CLI itself, or we can use our own wrapper CLI, in this case which is TF local, so that it can configure the AWS provider to use LocalStack instead. Let us jump to actually see some real code and see how this actually plays out. So we had spin down our LocalStack instance, and this is exactly our Terraform. This is exactly our Lambda function right here. So it's a simple Node.js based Lambda code which accepts an event and just sends the product in form of a JSON response. To orchestrate this, we have a function URL which we can send post request to, and we have a Terraform script right here which creates the Lambda function URL and basically creates a Lambda function first, and then it extends it as a function URL over here. So what's interesting here is that we have a provider.tf file as well, which specifies a LocalStack specific endpoints that we exactly want the Terraform to point to. So it will contain all of the LocalStack specific endpoints with services like Lambda, API Gateway, EC2, Elasticsearch, like all of these stuff all together. And this is what our Terraform script will be using while deploying resources to LocalStack. Let us actually see how it looks like. So first we are going to specify LocalStack start-t. This will again start our LocalStack in Docker mode, and it will detach itself. Next, we are going to just say Terraform init. So Terraform is a standard CLI interface of creating your infrastructure as a code configurations and then deploying them on the specific cloud providers. So in this case, we are using the AWS provider, but since we have modified this provider.tf file over here, it will be creating all of these infrastructure upon LocalStack itself. So Terraform has been successfully initialized. We can just say Terraform apply, and it will ask us to basically approve whether this infrastructure looks good to us. Since we are doing everything inside LocalStack, even if we are making some sort of a mistake, we can just spin down the LocalStack and we can restart the LocalStack in the Docker mode, and we can just get started with our own experimentation and learning again. So that's a very cool feature because you won't have to worry about all of those lingering resources on AWS that you might have to manually delete. So we are just going to say yes to this, and this will create the Lambda function over here. This might take a bit of a time, but right here you can see that the function URL has been created, and you can pretty much send out a post request to this and get it up and running. So we have a simple run.sh which exactly does that. So I can just say like bash run.sh, and it will send out a post request to that particular Lambda URL, and you can see that it is running out pretty successfully. Cool. So that was the essence of how our LocalStack plus Terraform integration looks like. Let's move to the next part of it, and that's about the GitHub Actions. So as I mentioned before, LocalStack is supported across a lot of integrations and CI providers as well, which includes GitHub Actions, Circle CI, and much more. For more docs on this, you can just check out docs.localstack.cloud/CI. But over here, I can show a very basic example of how that's exactly done. So I have a CI script, which is ci.yaml. And what it exactly does is it checks out our particular code on the repository, and then it starts LocalStack. So since LocalStack needs the CLI interface, and it also needs a Docker image to actually work out, we are installing the CLI interface right here along with the Docker image. And we just pretty much start LocalStack in detached mode over on line number 16. Once we do that, I'm just specifying the setup node so that I can use this zip functionality provided by Node.js right there. And I'm also setting up Terraform because I'm just using the official Terraform CLI to make my work out. If you want to use a wrapper scripts provided by LocalStack, you can just change these commands to tf local, and you can just install them beforehand so that you don't have to worry about setting up Terraform at all. So as you do the Terraform init, Terraform apply, auto approve, because we are just running this in an automated environment, it will just set up the entire infrastructure on GitHub Actions, and then you can start running your integration tests or maybe smoke tests or whatever you want to basically test your application out on your CI environment itself. To actually show this, I can just show how it looks on my own GitHub Actions. I have all of this code available on this repository right there, and as you can see on the action right there, this is how LocalStack test looks like. So it starts LocalStack by basically pulling out the Docker image and installing the CLI interface. And next, it just sets up the rest of this stuff like Node, Terraform, and it zips the Lambda function and it finally deploys it out. So with this, it becomes really easy for you to actually like test your cloud and serverless applications on the CI environment, because no actual resources are being created here, and it is just so handy. So if you spin everything down, everything would be automatically deleted, and you won't have to worry about the associated costs or anything of that sort. Apart from this, we are also like rolling out some new advanced collaboration features. One of them is Cloud Pods. With Cloud Pods, you can basically persist your running containers, which are otherwise ephemeral. But even more than that, you can actually take a snapshot of the state at any point in time, and then selectively restore, merge, and inject it into your instance. So the very essence is basically huge, because you can actually version, tag, and restore your LocalStack instances as state snapshots, which can be conveniently pushed or pulled like the Git objects itself. I guess most of you might be familiar with how the Git objects work. We are trying to introduce Git-like collaboration for the very like specific use case of LocalStack itself. So in the future, you can basically create your own local cloud pod. You can use it for a variety of use cases, and you can share it across different developers so that they can also get to see on what you're actually working out. This is especially useful for purposes like debugging and for creating reproducible workflows, because this is what LocalStack is pretty good at. So that was all for today's talk, folks. If you're interested to know more about LocalStack, I would be happy to chat further. You can reach out to me on my socials or follow LocalStack to know more about the AWS features we will be emulating, or the new features that we are building to make cloud development a breeze. Thank you.